Okay guys, so as promised, this video is going to be a presentation of many projects. So we're going to look at a humidity meter, we're going to look at some actuators, and we're going to look at some vibrating DC motors. We're going to make a solar charger and also a Bluetooth low energy igniter, which is pretty awesome. We're going to use a solenoid and control it with a MOSFET. We're also going to make a water meter out of a Bluetooth sensor. We're also going to make a power meter so you can measure power consumption in your home if that's what you're into. And we will also make a wearable out of an AT-Tiny, which is a very small Arduino. In the end, we will take a look at the autonomous car and also a GSM informant, which is pretty awesome, guys. This is a GSM-based reporter. It'll report data back to you wherever you are in the world. Let's get into it. Okay, so here's the first one, the humidity sensor for coffee. So this is a low-powered device, and here we have a container on the left with parchment coffee, and the circuit board or circuitry is on the right side. So we're going to cover this coffee container so that we can get a relatively stable humidity measurement out of it. And there we go. So this is still a product on the design table, so have to be careful with it. As you can see, it has this battery pack back here. Okay, so this is a typical battery pack for charging mobile devices such as cell phones and stuff like that. Okay, so here we have the circuitry. As you can see, the microcontroller is a Nano and it has an LCD screen on it. We're going to look at LCD screens later on. The Nano basically controls the temperature and humidity sensor, which in this case is a DHT22, a little bit more precise than the DHT11 we used in previous videos, in the intro. Okay, so let me plug this in back here. So it's USB cable. So this is kind of like plugging the microcontroller into a laptop for power, except in this case we're plugging it into the battery pack. And there it goes. So it's upside down apparently. And there it is. So the coffee and the temperature sensor, which is inside the cylindrical container, is spitting out this data. So 28.6 for temperature and 49.3 for humidity. Okay, and this is a very simple project. I mean, all it has is the microcontroller, the sensor, the LCD, and some passive components such as a pot. The sensor is in here. Okay, so this is a pretty simple, easy to do project. And what we're going to look at now is how to take this instantaneous measurement and just tweak it a bit so that we can get a much more reliable reading. Okay, so here is a smaller ESP8266 Wi-Fi module connected to a DHT22 sensor, and it is spitting out data to the internet. And in this case, it's actually being logged to this website where we have installed what's called an EMON CMS. So this stands for Energy Monitor Content Management System, and it's logging data for two time series. One of them is number 4, which is humidity. The other one's number 5, which is temperature. It is in real time, and it has an updated column, which shows right now 174 seconds. It updates at 190. So as soon as 180, sorry. So as soon as it reaches 180, the values change, and there it is. And this just keeps on logging, and it keeps recording this to a MySQL database. Now we can visualize the time series over a long period of time right over here, and this is much more useful. And we can play with this data viewer, select year. Here we had a power outage, I believe, for a couple of days, so a much more reliable way of storing data. Okay, so let's look at solenoids. This is an actuator, and it is controlled by a solenoid, and it lifts up this acrylic platform. Okay, and then it brings it back down. And this is all controlled by an Arduino, which is inside. So this is very useful for decorative projects and that kind of stuff. All right, the vibrating DC motor. Okay, so this is actually a 2-in-1 project. So there's a solar charger, which is this one on the left, and there's a vibrating DC motor on the right. So this is, like I said, 2-in-1. Let's look at the solar charger first. So this is a solar panel. I believe it's about a 3-watt panel. And on the back side, it has two 3.7 18650 LiPos. So that's a bunch of terminology, but it's basically just two 3.7 volt LiPos connected to this BMS, battery management system, which has a lot of circuitry to basically charge two batteries at the exact same level. Okay, and it connects to the solar panel, which is what's actually producing the electricity, which comes down these two wires into the balancing board or the charging board, and then, as I mentioned, the circuitry inside distributes the power evenly so that both batteries are kept charged at about the same level, which is very important actually for extending their lifetime and to prevent them from catching fire. Which actually sounds kind of important, right? Okay, so let's actually see the project out in the field. Let's take some measurements. Here we are measuring the voltage on the circuit board, which is 8.35. So that's going into the circuit board. And if we measure the voltage on the solar panel, it should be about the same. So let me try to get these leads in here. It's kind of complicated. There we go. Okay, and voltage is 8.35. Okay, so basically everything that's being put out by the panel is being received by the circuit board. Perfect. And if we measure the individual batteries, one of them is 4.18 and the other one is at around 4.19 or 20. So that's about fully charged. Okay, so now let's look at the vibrating DC motor, because this actually hooks up to the solar panel. So this is, again, a nano, and it's connecting to a DC motor, which is actually unbalanced. So it actually vibrates instead of spinning smoothly. And over here, we have the nano, which actually controls both the DC motor, and it does so with this L298 driver board, which is on the back side. Okay, so this is a board used for driving motors, and it's basically in charge of delivering a much higher amount of amperage because motors are high power consumers to a motor which would not be able to be delivered by a controller. So that is what the L298 and most other motor drive boards are actually used for. Okay, so now we are actually going to take a look at this in operation. Here it is. It's all connected, and it counts up to 8 seconds after it's turned on, and then it vibrates. There it is, and then it turns back off, and the LEDs also turn back off. That's important, because watch the LEDs come on, the red LEDs. You can see the reflection on the cardboard box. They turn on right about now, the motor vibrates, and then they turn back off, which means that the microcontroller actually goes to sleep to save power. Very important for mobile projects. Okay, now we're going to look at the BLE Igniter. So this is Bluetooth Low Energy. Much easier for connections and consumes a lot less power. Also very important. And it basically uses a MOSFET to control the flow of current. And we are using a Blueno Nano microcontroller. So this is a Nano with onboard or built-in Bluetooth Low Energy. So this is really cool because you just plug this in and it's discoverable. And this is what we're going to be lighting. An ST's rocket, which is definitely something you want to light from far away in case anything goes wrong. So this is what this is used for. So let's take a look at how it works. So here it is. We're outside. We're using a Bluetooth app, and there we have discovered the Blueno. We're going to write a value to it. And the secret or code word is high. That sends high to the pin on the Blueno, and the MOSFET lets the current flow. We're going to turn it off with the letter O. But the wick, as you can see, is already lit, and there it goes. Boom, just like that. We have a little bit of a problem here with the phone, but it's okay. It was protected by an acrylic plate, and so are we. Always got to be careful with these projects. So this is for an ST's rocket remote ignition. This is a really cool stuff. Okay. Okay, cool. So this is the circuitry. Okay, so let me introduce Altium Designer. Why? Because we're building all these projects and the idea is to make a product we can sell. After all, the only thing more satisfying than a working Arduino project is a profitable one. Nowadays, you can have your prototype or final designs printed by a professional PCB service. All you have to do then is make a cool case for it, slap your logo, and ship your product. Altium is a software that lets you drag and drop your designs onto a graphical user interface and automatically route all the connections for you and even send it off to get printed. Whether you're a freelance designer or part of a multi-company team, Altium has you covered with electronic and mechanical design, online collaboration, and even connection to manufacturing. Altium is the most trusted PCB design system with over 35 years of innovation and development. So when you're ready to make some serious money, Altium takes you from the idea to product faster and without the hassle. Download a free demo and try it today. Use the link in the description below for this video. And if you're ready to buy, you even get a discount. So if you're into saving water, saving the planet, this is right up your alley. So this is a Arduino Nano. It's just an Arduino, a Arduino Uno, which is an Arduino Uno basically. And you can see the LED on the right side turns on and off every 5 seconds, and that controls a solenoid valve, which lets the water flow. So whenever the LED turns on, it means that that pin is set to high, and the solenoid receives the command to open. And when it does, water flows through. And that's what's happening right here. And it does that 5 seconds on, 5 seconds off. So you're basically saving 5 seconds of water every time. And here is the Bluetooth water meter. So this is similar. This is also a Arduino Nano, but this is actually measuring the flow of water. So as you can see on the screen there, we have the flow of water being reported to the Bluetooth app on our mobile. So this is the power monitor. This is a current sensor, and it basically senses currents based on electromagnetic fields. So the way this works is this is a clamp meter, and it needs to clamp around a cable. In this case, we're going to be using the cable to this soldering iron that I have, and as you can see here, I have split it up because it can only wrap around one cable. The reason is that alternating current goes in and out of the cables every so often, and if you wrap it around both conductors, then the effect of the flow in one direction in one conductor will be canceled out by the flow of current in the other conductor in the opposite direction. So we're ready to plug it in here. So we're going to plug this into our 3.5mm jack right here, and we can see that the current is at 0.23. This is not calibrated, but it jumps up to 0.65 as soon as we turn on the soldering iron. Okay, so we can measure current. Great. Now we can keep tabs on our home power consumption.
So we love electronics because we love to create things. Now what if these projects that you create at home could make you some money, for all the time and effort that you've put into them? Well, many DIYers do just that. Once you've created that curtain roll-up motor or that water-saving shower controller that you wanted, or that crazy robot that you've designed, replace all of those components in breadboard with a printed circuit board and sell it. Nowadays, it's so easy to print your own circuit board, print a case for it, engrave a logo, and ship it. Altium Designer is an easy to drag and drop graphical software that you can use to throw your projects onto a file, make the connections for you, and you can send it off for printing. It's easy. Just print, sell, and let the money roll in. And if you get it today using the link in our description down below, you get a juicy discount on it.
So this is the ArmFlex Therapy wearable, and this is one of my favorites because in this case, the patient, which is very dear to me, needed to have therapy done on the right side of his body. So this was done so that he could wear it constantly and be alerted to certain movements. And this arm flex sensor, or this flex sensor, was used to monitor the state of his elbow. And the idea is that we have the AT-Tiny right here, and we have a buzzer to sound an alarm, and a power connector for this 3.7 small LiPo. And this is all connected to the sensor. So whenever the sensor is in a straight position, it will not fire the alarm. But when it is bent, it will fire the alarm. And it fits into this sleeve right here, which has two pockets, one of them for the battery and the electronics, and the other one for the flex sensor. This is the one where the battery electronics fits into. That's why it has to be a very, very small microcontroller. And the sensor fits into the second sleeve. Alright, and this sleeve basically goes onto the arm of the person who is going to be wearing it and needs to be notified whenever the flex sensor is bent. So let's power this up. And there we go. And let me just show you right here the way it works. There it beeps. There it didn't beep. There it beeps again. There it beeps again. So it doesn't always beep. It only beeps sometimes. And you might think of it as an error or a mistake, but that's actually done on purpose. So listen carefully. It beeps right there. It stops beeping. Even though it's still bent. There it beeps again. Okay. And we're bending it. It's not beeping. And there it beeps again. So the reason why this was done this way is because if you think about the actual real-world application, the person is going to be allowed to bend his or her elbow at a certain time for a certain amount of time. There are some cases where if you're holding up a plate or holding up a phone or a key, you want to be alerted to the fact that your elbow is bent, but you don't want to keep annoying the user with a continuous beep. So it was designed in such a way that there is a timing function that controls if it beeps for the first time and stops beeping after a while, and then 30 seconds later it will continue beeping to keep alerting the person. But we had to basically cover the scenario where the user would not want to be annoyed by the fact that you have this beeping buzzer on your arm constantly annoying not only the patient but the people around them. So this was one of the cooler projects that we worked on. And this one is the last one. This is the GSM Informant. And what this is a nano connected to a GSM module. This is the SIM900, and it also has a DHT11, which you might recognize. This is the SIM module, and on the underside it has the slot for the SIM card, which needs to be valid and registered onto a network. And what we're going to do is we're going to take measurements from the DHT11 through this signal pin, through the signal cable right here, and the nano is actually going to transmit that data out the SIM900. And we had to bring in this battery pack because the SIM900 draws quite a bit of power, much more than the nano is able to deliver through its pins, so we need to power it straight from its own source. And basically we are going to plug in these power cables for the SIM900 on the power rails that come straight from that battery pack. Right there, you can see the SIM LEDs light up. So the nano is being powered by the PC, but the SIM is being powered by the battery pack. Okay, so let's take a look at the data that is actually sent out. So this is the data being logged by the nano, which is received from the sensor, and this is the phone screen. And there it is, the first message coming in for temperature and humidity. Okay, and it was logged in the serial monitor behind us, or behind that screen, as sent and done. And I believe about 80 seconds later or something like that, it takes the measurement again. Just so happens that the temperature and humidity are the exact same number. And then it gets sent, and then it logs done, and in comes the second message. Great, so I really hope you guys enjoyed this video, and don't forget to like, share, and subscribe. See you in the next one.